This is Module 5 on electrical hazards. This material was produced under grant number SH05146-SH9 from the Occupational Safety and Health Administration, U.S. Department of Labor. It does not necessarily reflect the views or policies of the U.S. Department of Labor, nor does the mention of trade names, commercial products, or organizations imply endorsement by the U.S. government. Upon completion of this session, the participant should be able to identify major electrical hazards, describe types of electrical hazards, and recognize employer requirements to protect workers from electrical hazards. Electricity has long been recognized as a serious workplace hazard, exposing employees to electric shock, electrocution, burns, fires, and explosions. Definitions to some common electrical terms include the following. Electricity is movement of the free electrons between atoms. Current is the movement of electrical charge. Resistance is the opposition to current flow. Voltage is a measurement of electrical force. Electrical hazards can cause burns, shocks, and electrocution or death. Electrical equipment shall be free from recognized hazards that are likely to cause death or serious physical harm to employees. Never operate electrical equipment while you are standing in water. Never repair electrical cords or equipment unless qualified and authorized. Have a qualified electrician inspect electrical equipment that has gotten wet before energizing it. If working in damp locations, inspect electric cords and equipment to ensure that they are in good condition and free of defects, and use a ground fault circuit interrupter or GFCI. Always use caution when working near electricity. Under certain conditions, even a small amount of electric current can result in fibrillation of the heart and death. An electric shock also can cause the user to fall off of a ladder or other elevated work surface and be injured due to this fall. An electric shock can result in anything from a slight tingling sensation to immediate cardiac arrest. The severity depends on the amount of current flowing through the body, the current's path through the body, the length of time the body remains in the circuit, and the current's frequency. More than 3 milliamps can cause a painful shock, which can then cause an indirect accident such as a fall. More than 10 milliamps causes muscle contraction. More than 30 milliamps causes lung paralysis, which is usually temporary. More than 50 milliamps causes extreme pain, respiratory arrest, and severe muscular contractions. Death is possible. 100 milliamps to 4 amps, and the rhythmic pumping action of the heart ceases. Muscular contraction and nerve damage occur, and death is likely. Over 4 amps causes cardiac arrest, severe burns, and probable death. Electrical burns are the most common electrical injury. The 3 types of burns from electricity are electrical, arc flash, and thermal contact. Electrical burns result from heat generated by the flow of electric current through the body. Arc flash burns are high-temperature burns caused by an electric arc or explosion. Thermal contact burns are caused when the skin touches hot surfaces of overheated electric conductors, conduits, or other energized equipment. Thermal burns also can be caused when clothing catches on fire, as may result when an electric arc is produced. Electricity travels in closed circuits, normally through a conductor, but sometimes a person's body, an efficient conductor of electricity, mistakenly becomes part of the electric circuit. This can cause an electrical shock. Current enters the body at one point and leaves at another. Electrocution is fatal. It means to kill with electricity. Electrocution results when a human is exposed to a lethal amount of electrical energy. An arc flash is the sudden release of electrical energy through the air when a high voltage gap exists and there is a breakdown between conductors. An arc flash gives off thermal radiation or heat and bright, intense light that can cause burns. Temperatures have been recorded as high as 35,000 degrees Fahrenheit. Working with or near power lines can expose workers to electrical hazards, but these dangers can be avoided through safe work practices. These practical steps can prevent injuries from contact with power lines. Conduct a hazard assessment to identify and address potential safety hazards before work begins. Ask the electric company to de-energize and ground overhead power lines. Educate workers on safety procedures and requirements. Know the safe working distance for workers and equipment. Use non-conductive wood or fiberglass ladders. Wear personal protective equipment such as rubber insulating gloves and insulating sleeves and industrial protective helmets. Assume that all overhead wires are energized at lethal voltages. Never assume that a wire is safe to touch, even if it is down or appears to be insulated. Never touch a fallen overhead power line. Call the electric utility company to report fallen electrical lines. This table shows the minimum clearance distances in feet for different power line voltages. 29 CFR 1926.1408 provides requirements for safe distances. Note the value that follows 2 is up to and includes that value. For example, over 50 to 200 means up to and including 200 kilovolts. A ground fault occurs when there is a break in the low resistance grounding path from a tool or electrical system. The electrical current may then take an alternate path to the ground through the user, resulting in serious injuries or death. The ground fault circuit interrupter, or GFCI, is a fast-acting circuit breaker designed to shut off electric power in the event of a ground fault within as little as 1/40th of a second. There are several types of GFCIs available. Receptacle GFCIs are often found on construction work sites, outdoor areas, and other locations where damp conditions do or could exist. Portable GFCIs are an extension cord combined with a GFCI. It adds flexibility in using receptacles that are not protected by GFCIs. Extension cords with GFCI protection incorporated should be used when permanent protection is unavailable. The cord-connected type of GFCI is an attachment plug incorporating the GFCI module. It protects the cord and any equipment attached to the cord. The attachment plug has a non-standard appearance with test and reset buttons. Like the portable type, it incorporates a no-voltage release device that will disconnect power to the load if any supply conductor is open. Grounding a tool or electrical system means intentionally creating a low-resistance path that connects to the earth. This prevents the buildup of voltages that could cause an electrical accident. Grounding is normally a secondary protective measure to protect against electric shock. It does not guarantee that you won't get a shock or be injured or killed by an electrical current. It will, however, substantially reduce the risk. If the power supply to the electrical equipment at your site is not grounded, or the path has been broken, fault current may travel through a worker's body, causing electrical burns or death. To protect a worker from shock, electrical tools must have a 3-pronged plug that is used with a grounded receptacle, be double insulated, or be powered by a low-voltage isolation transformer. Never remove the 3rd prong or grounding pin from a 3-prong plug. An adapter may be used to accommodate a 2-prong receptacle, but it must be attached to a known ground. Lamps for general illumination shall be protected from accidental contact or breakage. It is important to ensure that the sockets are also properly grounded. Special care needs to be taken with electrical equipment in damp or wet locations. Cabinets, cutout boxes, fittings, and panel boards must be weatherproof. Additionally, switches, circuit breakers, and switchboards must be in weatherproof enclosures. Water leakage into light receptacles or fixtures can cause a major fire hazard. What is the hazard in this photo? What is the hazard in this photo? This 3-prong grounding plug has the ground prong broken off. Equipment grounding only works when there is a permanent and continuous electrical connection between the metal shell of a tool and the earth. If a wiring defect in the tool allows an energized wire to touch the tool's metal shell, Grounding provides a low resistance path to earth for the resulting current. This will generally allow enough current to flow so that a fuse will blow or a circuit breaker is tripped, thus turning off the electricity in that circuit. If this grounding path is broken at any point, the tool is not grounded and the operator is at risk of shock or electrocution. Discuss the following accident and how it could have been prevented. The lighting technician was attempting to correct an electrical problem involving two non-operational overhead lamps. He proceeded to the area where he thought the problem was. He had not shut off the power at the circuit breaker panel, nor had he tested the wires to see if they were live. He was electrocuted when he grabbed the two live wires with his left hand and then fell from the ladder. How could the accident described have been prevented? Examples of how to prevent electrical accidents include the following. De-energize electric equipment and use lockout and tag procedures to ensure that the equipment remains de-energized before inspection or repair. Keep electric tools and equipment properly maintained. Exercise caution when working near energized lines or equipment, and use appropriate insulating protective equipment. These are the resources for this module.